Hi Year 11, this video is designed to give you some help with assignment 7. It's also probably going to be quite helpful for you for assignment 8 as well, mainly because it's giving you the overview of what's actually happening in the nephron. There are some questions about that in assignment 7, and assignment 8 requires you to make a model. And realistically, if your model looks like the diagram that you've got in front of you here, that simple model, well, you're in a really solid place. Now, realistically, before I go through all the answers, I want to go through what's actually happening in A and B and C and D and E again for you. And I know I've done that in my YouTube videos and other places, but it's worth you checking so you've got a clear understanding of what's happening here. Okay, so section A, that is your glomerulus. You've got your afferent arteriole coming in and your efferent arteriole leaving, and then you've got this big bundle in the middle, which is your glomerulus. It is surrounded by this C-shaped capsule, and this is your site of ultrafiltration. So what that means is that you're going to have all the constituents of the blood, all the things that are in there that are smaller than a protein molecule, are going to be passing through into the Bowman's capsule. They're no longer in the blood, and they then make a new fluid called the filtrate. That fluid's going to have water, it's going to have amino acids, it's going to have urea, it's going to have glucose, it's going to have salts, and it's going to have water, if I've not already said that. Okay, because basically the purpose of your nephron is to control the amount of water in the blood and to remove substances like glucose and to remove substances like urea from the entire body, but also to make sure that you're going to be able to get some of those things that you filtered out back. Okay, so section A, you've got your filtering. Section B, you begin reabsorption. Section B refers specifically to this tubule, this purple thing here. This is your proximal convoluted tubule. The thin red line near it is the beginning of a blood vessel network called the vasa recta. Capillaries that absolutely, for want of a better term, cake the proximal convoluted tubule, all the purple bits. So they're massively surrounded around it. In section B, you have reabsorption, specifically your active transport. So you have the reabsorption by basically the use of energy to pump the substances back into the blood, the stuff you want to get back. Substances that are overtly taken back will be amino acids, will be glucose molecules, because you need those to be able to carry out respiration in your body cells, and you need those to be able to make the building blocks of protein. So section B, that's the beginning of your reabsorption, but specifically you have active transport happening there. Section C, down here, this downward hairpin thing is called the loop of Henle. At this point, you've removed back into the blood all of the glucose and the amino acids. The purpose of the loop of Henle is to allow you to reabsorb water. Okay, you have 20 litres an hour of water going through the kidney. If you had 20 litres an hour coming out of your bladder through your urethra, i.e. you were weeing 20 litres an hour, you're dead. Okay, so that's not what happens here. Most of that water is going to be reabsorbed. That will happen in section C. That will happen passively by a process called osmosis, which is a fancy way of describing the diffusion of water. It goes from where there's a high concentration of water in the loop of Henle to a lower concentration in the blood, and it reabsorbs that. The same happens with salts. Section D and section E, the section D is referring to your distal convoluted tubule, so you have additional reabsorption of salts, and your section E is your collecting duct, which will feed into the ureter and down to the bladder. And at that point, you're going to have a really high concentration of urea, you'll have some water, you'll have some salts, you'll have urine, okay, as you know it. Anyway, that's your general thing, and for assignment 8, that was pretty handy. Let's talk about the answers to the questions. Where does filtration happen? In the glomerulus and Bowman's capsule. Where does reabsorption happen? In the proximal convoluted tubule and the loop of Henle. What is active transport? The active pumping, the use of energy to take back materials against a higher concentration gradient. So by that I mean there is a relatively large amount of glucose in the blood. There is less of that in the actual filtrate, but you still want it back. The glucose is precious to you, so you pump it back, you spend energy. That is active transport. It's transport that uses energy that goes against a concentration gradient. What is osmosis? Osmosis is the diffusion of water from a high to a low concentration gradient through a semi-permeable membrane. That's describing it basically going through the membranes of a cell. What is reabsorbed by osmosis? Specifically water and some salts that will be absorbed in that structure. How does the layout of the nephron support this? It has that loop thing. So this loop thing provides a really, by all the water going through this, it provides a larger surface area for water to be absorbed. And as the concentration of salts is higher, it makes it easier for basically, how does the structure allow this to happen? By having a higher concentration of water here, it's easier for that water to be reabsorbed. So it goes from here to here. And that means that you've got this opportunity to maximize the amount of the absorption of water back from the loop of Henle into the blood vessels. Okay. What is reabsorbed by active transport? I've mentioned that, your glucose and your amino acids. How is the kidney supported to do this? Massive blood flow. Okay, so it has a really high blood supply, really high supplies of glucose, providing energy via respiration to those pumps to be able to get all of that in. Okay, what substances are present at the kidney? Well, you're going to have glucose, urea, amino acids, water, and salts in section A when your ultrafiltration happens. In section B, effectively, you're going to be losing things like your glucose and your amino acids. So they're going to be being absorbed. So as you go through section C, so section B, these will begin to decrease. And when you get to section C, there's none of them, or there should be none of them, in the filtrate. Section C, you'll have urea and water and salts. The key idea here is that between section C and section D, the water and salt concentrations are dropping. There'll be less and less of those as they are reabsorbed into the blood. When you get to section E, all you are left with is urea and water and salts after large volumes of water and significant volumes of salts have been reabsorbed. Urea is not reabsorbed. Okay, the big old table task. I've done that. Okay, the first part of the video was me going through that, and realistically, if you've done your posters as well, you'll be very comfortable with that. What I would want to stress, how you relate that to the general kidney structure, how you relate that to the medulla and to the cortex. What I need you to take on board when we are talking about section B and section A, we are in the cortex regions of the actual kidney. Okay, when we move into section C, we are entering the medulla. So one of the things that's described about a medulla is sometimes in textbooks you'll see it referred to as a salty medulla. And the reason that it's a salty medulla is that will help with the absorption of water. It will mean that the concentration of water is going to be it's going to be supporting that diffusion of water from the loop of Henle back into the vasa recta. Okay, so you don't need to necessarily go into huge levels of depth here, and like the kidney is more complicated than I'm describing. But in terms of setting you up to go well in this internal, that's your basics. Know where the filtration happens, know where the reabsorption happens, know which stuff is being taken back, understanding the differences between section B and section C, and recognizing that by the time you've got to section E, you've got urine as you know it. Okay? With that in mind, we can start talking about how the environment affects how this process works. And that's the focus of assignment 9 and assignment 10.